The parts of a long bone. You've got the diaphysis, which is the shaft in the middle. You've got the epiphyseus, which are the two kind of bulgy ends. And you do have two epiphyseus. If you think about directional terms, you've got a proximal closer to the body and a distal further away from the torso. Torso. At the epiphyseus, you have the spongy bone. In the center, in the diaphysis, you actually have something called a medullary cavity. The medullary cavity is usually where you're going to find the bone marrow. Now, just like in our cartilage, we have this membrane that surrounds the bone here called the peri-around ostium. Osteo is bone. We also have these epiphyseal plates at the end here inside. These are actually also called the growth plates, just so you are aware. So looking at this picture, see this lining on the outside here? This is the periosteum. Here's my compact bone. Here's my spongy bone in the middle. You will also notice that I have this white lining on the inside. So if this is my periosteum around it, this is my endosteum. This is that same kind of membranous covering, but instead it's on the inside. Now, the periosteum and the endosteum are both going to contain blood vessels, and they're going to contain nerves. So you've got blood vessels and you've got nerves here, and you can actually see the blood vessels here. They did a very good job of showing that in this picture. The endosteum also has blood vessels and nerves. Now think about this for a second. I've got compact bone, I've got spongy bone, both of which have the, sorry about that, have the ability to anchor down into the bone using something called perforating or Sharpie's fibers. They literally hold this in place so it's not rubbing against the outside, which makes sense because the outside has the blood vessels and the nerves. I don't want them being yanked up and down along sandpaper. That would be very painful. As well as that, though, you also have the osteoblasts and osteoclasts, both on the outside and on the inside. Now, why is that important? Well, if you think about it, that makes sense. Where do I have room to grow? I only have room to grow outward from here, because if I try and grow in here, this is compact bone. There isn't any space. I do have space in the middle here where I've got all that spongy space that I can actually grow into. That I can actually grow into. So it makes sense to put these cells in those two places. Now, flat and irregular bones. Flat bones kind of look like a sandwich with the two pieces of bread out here, and the filling being spongy bone. Short and irregular bones kind of look like an M&M. They've got hard compact bone along the outside, the shell, and then they've got spongy bone dead center, the chocolate. One of the things with them is they don't contain a diaphysis, they don't have a shaft, and they don't have an epiphyseal plate. They don't have a growth plate. Some flat and irregular bones in the skull also have air-filled cavities called sinuses, and I'm sure if you've got allergies like I do right now, you know exactly what sinuses are. So bone development. You've got two types of bone development, intramembranous ossification and endochondral ossification. Intra, inside membranous, inside a membrane. Endo, inside chondro, cartilage ossification. So intramembranous ossification begins about the 8th week of embryonic development. It's completed by the age of 2. I'm sure you've seen a baby's head and it's got soft spots, right? You've got these centers of ossification where ossification begins and then starts to expand. If you think about Resident Evil, any commercial of Resident Evil, they show those red dots and then it starts to spread out, kind of like coronavirus. that's kind of what we're talking about. So if you look at this picture, you can see these little speckles here. These are centers of ossification. They start growing bone and then it starts to spread until they hit each other. Now for this baby, it's got soft spots, fontanelles, which you can see here, fontanelles, that are membrane-covered spaces between the developing bones of the skull. Why? Well, one, if I'm a mother giving birth and I have to basically shove something the size of a cantaloupe out of a hole the size of a kiwi, I want it to shrink. Having these bones not be solid means that they can compress down. The other thing that's happening very quickly for this baby is they are developing very quickly. Their brain is growing very quickly. If you've ever seen the head of a 2-year-old, their head looks too big for their body. One of the reasons is because their brain grows so fast. Having the ability to accommodate that growth by having soft bones there actually helps. So progenitor cells in the membrane, progenitor, the beginning cells, become osteoblasts, remember blast build, that surround collagen fibers of the connective tissue membrane, forming tiny trabeculae of woven bone that will eventually become osteocytes. So you've got these osteoblasts. Here's an osteocyte already surrounded, but I'm starting to make these little trabeculae in the center. Additional osteoblasts form on the surface of the trabeculae, making them larger. Eventually, they grow together to form spongy bone. So this is one little thing, but if you look here, I'm starting to actually grow that kind of network of trabeculae in the spongy bone. Within the spaces, the cells with will specialize in the red bone marrow. Around the bone cells will develop into a periosteum, and the outer cells begin to form the compact bone. So if you look here, you can see that I still have spongy bone here, but things are getting more solid around the outside. Here, that kind of darker pink is the periosteum starting to form. So for the most part, these are going to be your flat bones. This is how your flat bones develop.